Okay, so we're not doing section anything, are we? We're doing study guide. So we're just going over some of these questions from the study guide from chapter 8. Alright, so number 15. This is that word problem. And it says he's hanging some stuff for a square dance, who cares? And it says using a book. Now this is kind of crazy. It says using a book to sight the top and the bottom of the barn, he can see that he is 15 feet from the barn. Let me pause this for a sec. All right, here is the deal, the dealio. You guys ever say that anymore?
I said that. I said
Kids used to. Kids used to say that. I never said it, but kids did. I was too old. I was old. When I was a teenager, they used to say rad. That thing's rad, or radical, you know. And so I used to say that, and we just thought we were so cool. But I didn't introduce her. I thought you already talked to her. Okay, this is Miss Barry. She's Mr. Barry's daughter, and she goes to Liberty University, and she's a math education major, so she wants to be a math teacher. So she's working on her practicum, is what they call it, and where she has to observe a teacher and that kind of thing. Probably see all the bad things that I do, so she can tell her teachers what she doesn't want to do. Right, yeah, Taylor. Yeah, Taylor Swam's here with Mrs. Beatty, right? Yeah. And she's going to Liberty now again for the second time, so very excited about that. She did. She went to Liberty and then she went to Delaware, but they started a field hockey team at Liberty. Oh, I'm recording. And and so she gets to play field hockey there, and it's the very beginning. It's the first time they've had a field hockey team. Let's go red for it. Oh, that looks like a red barn right there, doesn't it? Ruby red. All right, so watch this. This is the barn right there. Okay, actually, let's make the bottom green for grass. Okay, there we go. That doesn't look very red, does it? Let's go red. There we go. Really wide? Well, what I did when I did this on my, I just did this. That's the barn. Okay, you follow me? Okay. So what's going on here? Let's pay attention. What's going on right here is this. I'll tell you what. I couldn't do this on my regular paper, but we'll just make it a square. It's a square book. Okay. I'll make it a little extra big. Actually, make it a little even bigger. It's a big old book. All right. So what we're going to do is this. We're going to tilt it, I believe. Oh, that's not very good. That's way too big. Yeah, that's way too big. Let's do this. Where have you been?
That's what his name is.
Actually, let's do this. Let's make this bigger.
Mike?
Oh, I don't know. Let's do this. Let's tilt this up. Are we listening? Tilt this up so it goes to here. This is not exactly. Let's tilt it maybe a little bit more. And we're going to have to move it so that it's kind of, watch. See, that's the line of sight. Where do you think? About right there?
That's cute.
No. Maybe like that? Oopsie daisy.
You should have a math bond.
Shh, hush. Look, if you're going to say something, contribute to what we're trying to do here. Watch. I want this thing to come down like that, and then I want that to go like this. So watch, if I just tilt it a little bit more, about like that. Let's see if that works. Nope, that's going to be way short. That's going to be pretty close. I could tilt it a little bit more, right? Shh. Not unless you're contributing. Are you contributing? Or are you just complaining? No complaining. Alright, now watch. If I took this and it went straight up, that's pretty close. And this... Oh. Well, I tell you what. I'll fudge it just a little bit. Watch this.
Hey, it's like a right angle.
Well, it's supposed to be a right angle. That's the whole idea, okay? And watch this. We'll bring this down. See, I fudged it a little bit. But that's alright, because I'm tired of playing around with this thing. Yeah. Okay, you get the idea? Forget that. You don't like that one? Or that one or that one. Okay. Is that better? Oh, looks great. Stop, you babies. Okay, so here we go. Let's do the math. Okay, so here we go. 5 feet from the wall, right? Or the barn. So from here, 15 feet, right? 15 feet away is what it says. And then 5 feet up, right? So from here to here is 5 feet. Agreed? We good? Okay, so what in the world can we do? How can we do this? Look, I don't even know a side of a triangle, do I? Of this right triangle. So how in the world am I supposed to find anything? Well, watch this. If this is 15 right here, we're going to do that geometric mean stuff. And then this is a right triangle. So what's that? That's 15, isn't it? Okay. If this little bit's 5, look at this. From here to here, right there is what? It's 5. Now look at this. We have, let's get rid of this so it gets out of the way. Oops, see daisy, let's do that. Let's get rid of this. Let's get rid of all this just because it's kind of looks ugly and gets in the way. Okay, there we go. Look what I have. I have a big right triangle because that was a book, right? And a book makes a right angle like that. So, and it lined up to the bottom and it lined up to the top. That's a book. It's 5 feet from here to here, and it's 15 feet to the barn. So I know this side. This is a geometric mean, isn't it? Now remember, it's the geometric mean. How do we do geometric mean? Set it up like this. So this right here, you agree? It's taken from the right angle perpendicular to the hypotenuse, okay? So if I have a right angle here and a right angle here, that's my situation with geometric mean. This is the altitude, isn't it? Remember doing that? The altitude or the height, that's the altitude, and that's a geometric mean. It's a geometric mean between what and what, though? Between the two segments of the hypotenuse. Do you remember that? So it's between this segment right here and this segment from here all the way down to here. So what are my numbers then? Well, I don't know what it is from here to here, do I? So let's call it x. So 15 is a geometric mean. Matt, you with me? No, you're somewhere else. Okay, up here. So 15 is a geometric mean between what and what?
X and 5.
X and 5, that's right. X and 5. You remember that, don't you? Most of the time our triangles were kind of tilted. So that... I'm not even going to do that. But you remember, most of our triangles were tilted where this was like on the bottom and this was straight up and down. But this one's just on its side a little bit. But it's the same deal. This is a geometric mean between the two segments of the hypotenuse. And then guess what we can do? We can cross multiply. So 5x equals, what's that, 225? And then divide that by 5, 45? Okay. So x is 45. So that means the length from here to here is 45. Is that what they ask us, though? Now they ask us how tall the barn is. So it's 50, that's right. So from here to here is 45 plus this, and you add them up and you get what? 50. 50 feet. And that's how tall it is from here all the way down to there. So that was a little bit weird. I don't believe I have that on a test. I'm positive I don't have that on the test. But it's good to do. Yeah, it's not hard once you figure out what the picture looks like, is it? All right, it's pretty easy because it's just a simple geometric mean problem. So there you go. Make sense?
Yep.
Good. All right, what are we doing now? 21, 24. All right, so let's do 21. Let's see what that one looks like. Ah, another word problem, huh? Okay, this is actually an easy one. It says, Alexi walks 27 meters south and 38 meters east to get around the lake. So let's say that's our lake, all right? And so she wants to get around the lake. And she goes, she's walking in the grass, so we'll make it green, right? She goes, what, 27 south, right? So she goes 27 south and 38 east, is that right? To get to there. That looks better than the first time I did it, doesn't it? Because I drew the lake first. So that's 27, and what did I say? This is 38, okay. So she didn't have a boat, all right? She can't swim, so she can't go straight across. So what does she do? She goes this way, and she goes this way, all right? I guess there's bears and stuff in here, so she couldn't just go around the edge of the lake, all right? Or there was woods. So they had a path, let's say. So the path went this way, and it went this way. And it said her little friend, I think, sister, How many meters to the nearest tenth did Alexi's, her sister swim? She wanted to swim directly across the lake to get from point A to point B.
That would have been
All right.
fast.
Well, it depends how fast you can swim, right? I mean, if you can't swim, usually you can walk faster than you can swim.
Yeah.
And plus, it's hard to swim a long distance. So, I don't know, 27 meters isn't that long, so maybe it was quicker to swim. But she can't swim anyway, this girl right here. So what's that distance? Look, all that mess just to do what? Math-wise, just to do what? Yeah, by what? Pythagorean theorem, right. Okay, so 27 squared plus 38 squared equals whatever distance squared. You can do the rest of that, can't you? I don't have to do that. That should be easy. So that was pretty simple. That wasn't hard at all, was it?
I did that, but I got like a different answer.
Oh, you
What
did?
The book said.
Uh-oh.
Oh.
Like the answer said for 21 that it was 18.4, and I got something like 46.6.
Oh, really? Okay, well, let's try it. Maybe I'm not seeing something. And you take that and square root it?
Oh, that's because you didn't. It
Did
was
you-
how much
Oh, you forgot. I
she
forgot the
saved.
D's.
Oh, I didn't read the problem right, huh?
See, because that's what we got.
What is it? 46 point what? 6?
6.
Okay, sorry about that. Thank you, Alex. I didn't read the problem correctly. What does it say? It says, how many meters to the nearest tenth did Alexi's sister save by swimming? Okay, so if this is 46.6, how long did Alexi walk? 27 what? Plus 38, right? Did you agree?
Yeah.
What's that, 65, right? So how much did she save by swimming? So what do? You just take the difference. Okay, so 65 minus, hopefully that works, 65 minus 46.6, there you go, 18.4. Okay, so she saved 18.4 meters by swimming across. That's a good example. I didn't do that on purpose, but it's a great example, because I probably would have put that. Why? Because I was too lazy to read the problem carefully. All right, and I didn't do that on purpose, but that's what happens a lot, isn't it? You look at something and you kind of assume you know what they're going to ask, but don't assume anything. All right, 24. All right, let's see what we got for 24. Another word problem. How about that?
Mr. Hammer, are there any word problems on your test?
I don't think so.
Oh, thank God.
All right.
The ones that I get wrong.
Okay, this says, it's just a matter of drawing the picture, though, right? Once you draw the picture and understand what's going on, it's not that hard
But
to
can
do.
I tell you what?
So let's look at it. Again, they word this kind of weird, I think. It says, shh, guys, please. Okay, well, let's read it. It says, Jason is adding a climbing wall to his little brother's swing set. All right. So basically, I mean, you know how a swing set kind of goes like this, right? And then you got a swing. See that? Okay.
It's
So-
like the altitude thing.
All right. But what we're going to do is we're going to think of looking at it on its side because you're building something against it. So, like, if you looked at it on its side, just think of it as a, I don't know. The swing set thing bothers me. If you just had it against a wall or something like that, it'd probably make more sense. But so here's a straight up and down wall. What does this guy want to do? He wants to make a climbing wall to this. Okay, and what's it said? Yeah, and a climbing wall is a little bit of a swing set. He starts building 5 feet out from the existing structure. So if this is the existing structure, right, and he's building it 5 feet out. Oh, he starts building it 5 feet out, correct?
Yeah.
Okay, so right there. So that's 5 feet, and he wants to build a wall, correct? Or a climbing wall. So where are you going to climb? You're going to climb up to here, aren't you? You see that? So this is kind of like the wall or the side of the swings, and so he's going to start it 5 feet out, and then you can climb up this thing, right? You put little, I don't know, you put little bumpy rocks on it, right? So you can grab onto something.
It's like a
Okay, does it make any sense?
Yeah.
All right.
Yeah. It says that the one angle 60 degrees.
Well, the swing is going like this way, right? This is off to the side of it. So here's the swing, right? Like if it went across and the swing's kind of coming here, you're going whoo, doo, like this, okay? And you gotta make that sound. And what's it say about the angles? It says it's got to have a 60-degree angle. So where do you think that 60-degree angle is? About right there, okay? Because that's the steep one, right? And this would be what? 30. So it's 30, 60, 90. So this is the short side. Just as review, do you remember what our relationships are? For a 30, 60, 90, the hypotenuse is how much of what? It's twice the short side, right? Okay, we relate it to the short side. Then what was the other one? The longer side. Good, it's the square root of 3 times the what? Short side. My other class never uses this, but this is how I always remember it. 2 is the same thing as the square root of 4, isn't it? The long side is just a little bit shorter than the hypotenuse. Remember, the hypotenuse is always the longest side of a right triangle. So I think of this. I think a square root of 3 is just being just a little bit shorter than the square root of 4, isn't it? Right? Square root of 4, square root of 3. Does that help anybody at all?
No.
It doesn't? You just memorize square root of 3?
I just memorize the formulas.
I don't know. It helps me a little bit when I think of this. All right. I mean, to be truthful, at this point, I've taught this for a lot of years now, so I remember square root of 3. But I figured for somebody that just learned it for the first time, you know, how do you remember square root of 3? It's just a little bit smaller than 2, right? Anyway, maybe. I don't know. What are you trying? It says, how long should the wall be? Is what? So we're looking for this. We're looking for x. Okay, that's what we're trying to find. Okay, so what do we do though? Short side, hypotenuse. What's the relationship? It's just twice. It's easy, right? The math is simple, isn't it? It's just understanding what we're trying to find. Because it's 30, 60, 90. I didn't have to do any trig. I didn't have to do anything like that. I didn't have to do Pythagorean theorem. I couldn't do Pythagorean theorem because I only know one side. All right? But I can see it's a 30, 60, 90. The hypotenuse is twice as long as a short leg, so the hypotenuse is 10. The short leg is 5. We good with that? Make sense? Lee, does that help a little bit? Believe me, it was confusing for me, all right, when I read it. And I had to think a little bit about what was going on. And they understand everything? Wow.
She said this chapter before, so that means everybody's going to get F.
Did you know you understand everything? How about that? How's it feel to know everything? That's what Alyssa thinks. Alyssa thinks you guys know everything.
They get 100 on like all the tests.
It's because they study for hours and hours for
They're
it.
forced to. I don't think
It doesn't matter it doesn't matter why. I'm just telling you the reason that they well, I guess it does matter why.
She's a good cook.
Who, Leah, you're a good cook? What did you cook?
Korean food.
Korean food,
Oh, I
really?
want
Was it good?
Korean rice. I want to see what
No.
It's Mexican rice.
Let's see. We did 15, we did 21, we did 24, now we're doing 31. Alright, here we go. Let's do this color. 31.
I like this color, it's my favorite.
Yeah, I like this. Except I'm not sure, like, see where it looks like a candy cane?
It's like
I wish it wouldn't do that. I wonder if it does that if you get thicker. Let me see. Yes, it does, doesn't it?
Figure's so cool though. I like how it looks.
Alright, here we go. 31. Alright, here we go. Finally doing some trig. Don't you love doing the trig? No. Sure you do.
Wait, what is the trig?
Sine, cosine, tangent.
Oh my god.
Alright, here we go. This is 25 degrees right here. Now this is not, we started now, so let's pay attention. This is not a special right triangle, is it?
No.
So that's 25 degrees. So we can't use 30, 60, 90. We can't use Pythagorean theorem, can we, to solve for x? Because I only know one side. I got to know two sides to be able to use that. So really the only option I have is using the trig functions. I could use this angle down here if I wanted to, but why bother? It's just another step, right? Use the angle that they give you. Getting stopped up again. Okay, here we go. So 25 degrees. What do we have? What do we know? We know this side right here is 15, right? That's opposite. What is this side to 25? It's adjacent. This would be hypotenuse, wouldn't it? So this one right here is adjacent, opposite. Which trig function? So tangent of 25 equals opposite over adjacent. Opposite over adjacent. Look, the math is a little more confusing than what it normally would be, but it's not that bad. Look, you should be able to do this in your head, shouldn't you? Take the x, put it up here. Take the tangent of 25, put it down below. So x equals 15 over the tangent of 25. You should be able to do that at this point, shouldn't you? Okay. And now I just plug and chug, right?
I did tangent 90. Like I screwed up.
Yeah, you don't want to do the tangent of 90. So it's 15 divided by the tangent of 25. 32.
0.2.
Did they tell you to? Yeah. Yep, 0.2. So it is a side, so 32.2. What's that, Matt?
No, I just don't like the number 32.
You don't like that number?
Naturally.
What you got against that number?
I don't know. Just like I think the best numbers are 9 and number 1. But the number 8 is
9? You like 9?
I love 9.
9.
Number 8 is the worst.
Eight is the best.
8 is
8 is a dumb.
I like 11.
They should
That's what I
change.
like.
Do you like
I
11?
like number 10. I'm always number 10.
I thought it's number 4.
When listen to this story. Are you listening? When I was in 2nd grade, I remember this. Our teacher, this is almost cruel,
In the 90s.
but in the 90s, sure, it's the 90s. Back in the 70s,
I was in 2nd grade.
it was in 1972 is when I was in 2nd grade. Our teacher would number us,
Oh, I remember 21.
and we were numbers, and I was number 11. And then she,
I was number 10.
I don't know, I don't think, listen, it's my story, hush. She would number us. I don't think she called us by the number, but I don't know how I remember it. But we'd have to sit in a certain number and say you're 11 or I don't know what
Because I
it was.
remember my number in 1st grade.
Oh, really?
Was 10.
I was 21.
And so I was 11, and so that was always my favorite number. Isn't that terrible though for a 2nd grader to number you? I don't even know if she knew my name, but.
Yeah, I'll
All right, let's do
That's how I remembered,
36.
like, who everyone in the class was. I knew them by their name and their number.
Yeah, on our papers, you always had to write your name and your number so their papers were in order. They always collected-
So that's like an elementary teacher kind of
It
thing.
was so stupid.
That's why I went to
I was
Bible
like,
and
why
stuff
do we
like
need our number?
Elementary, my dear.
All right, look at that pretty color. Isn't that nice? Can you see that all right? All right, this is X. This is 15, 24, 33 degrees. All right.
We should pour water.
Let's do this. We're trying to solve for X, correct? Yep. It just says solve for X. This is what we're looking for right here. So what do you think? Are we going to use sine, cosine, tangent?
We're gonna use.
We could use...
Yeah.
Can you use the regular sine? Like the sine of 33? Could you only use that with what? You can only use just regular sine. Just sine, cosine, and tangent with right triangles. Okay, we don't know it's a right triangle, do we? So what can we do?
And, cosine.
Well, we could do the law of sines.
Law of cosines you really couldn't use because look, if I use law of cosines, you don't know this angle, you know the side that's opposite, but you would have to know two of the other sides, wouldn't you?
Well,
So you
Matthew
couldn't do
Southern,
that.
Chandler Swam, Christian Swam, please come to the office for an early dismissal.
So law of what?
Who's he?
So let's use the law of sines. How do you know? Shh, come on, guys. I give you a lot of leeway, but when I'm ready to teach, it needs to end. Okay? So look, the law of sines. If I know an angle and I know the side opposite that angle, that's a good indication that I'm going to use the law of sines. Is that all right? So let's give it a shot. You remember how to do this? You could. A lot of books go sine of 33 over 15. For some reason, I don't know why, I always learn it like this. 15 over the sine of 33 equals, and then we got to find this, don't we? So do I know the side opposite that? Yeah, it's made perfect for us, isn't it? So 24 over what? The sine of x. And now what do? Cross multiply. So it's 15 sine of x equals 24 sine of 33. Divide by 15. I'm running out of time, but You can do this on your own. Actually, let's do this. So watch. You're going to have to put this in your calculator and then do what to it at the end? If you get rid of this, x is equal to the inverse sine. Okay, you got to do the inverse sine of all of this. Put in your calculator and you should get the answer they give you in the book. Okay? All right, so no homework tonight. Tomorrow I'm going to give you that practice test to work on. All right, so that's what we'll do tomorrow.